Hello everyone and welcome back to another video. Today we'll be taking a look at a British Informatics Olympiad question, and we'll be taking a look at question 3 from the 2020 paper. So let's have a look at the question. I'll let you have a quick read of the question before I jump to the whiteboard and explain what I understand from it and the solution. Okay, so pretty much what the question is asking us to do is, we have a certain number of letters, like let's say A, B, B, and then we want to print like the 7th or nth permutation of these particular letters when they're arranged alphabetically. So, and now how exactly would we go about doing this? So pretty much, if we want to order this systematically, then we would basically do so in such a way that we would have A as the first character, and then or B as the first character, and then from the A we can have the A another A stemming from these A's, and then B's stemming from these A's, and then likewise with the B's we'll have A's first, and then we'll have some B's. Okay, so pretty much how this works is that the number of permutations of A, B, B is the number of permutations of, it's basically the number of choices for the first character, in this case which is 2, plus all the permutations which these characters then lead on to have. Okay, so then that's basically the recurrence relationship we have, that the number of permutations for A, B, B is the number of permutations when we have A as the first character, plus A, B, B, and then we need to add that to the number of permutations when we have B as the first character, and then A, B is the next 3. And that total becomes the number of permutations for our larger one. And then we just repeat this process again and again. So for example, if we want the number of permutations for A, B, B, then we take the number of permutations with A as the first character, plus the number of permutations of B, B, and then we do the same with B. We take B as the first character, and then the number of permutations of A, B. Eventually we'll reach a base case, and this base case is when either all the letters are of the same type, e.g. BB, because there's pretty much only one unique way to order BB, which is BB obviously, and or when we're rearranging AB, then we'll basically get two single letters A and B, and that's our second type of base case. When we have and then once we reach these base cases, obviously if you're familiar with recursion, then we basically just start unwinding the whole stack, because we're basically finished with our recursive code. And now we just need to determine that for all possible sub-branches. And then we get the number of ways in which AAB can be rearranged. Now you might be thinking, well, okay, this is all well and good, but how does it help us get the 7th way, or the 3rd way, or the 5th way to get them rearranged? So to that, that's what we're going to explore now. So let's say it's starting with A. How many are there? How many do they say in the question? So from A there are 5, and from B there are another 5. That makes sense because they're symmetric basically. So let's say from A there are 5, from B there are another 5. Which means if we're looking for the 7th one, then we know that it can't fall in this, since only the first 5 fall in this, i.e. the 1st, 2nd, 3rd, 4th, and 5th. And then we know that 6th, 7th, 8th, 9th, and 10th fall within B. So then we know that our search gets limited to B. And now we can apply this again and again. Because if we see from BAAB, we know that BAAB, this has 5 different permutations. And now we're looking for the second one within these 5. The reason why we're looking for the second one is because we know that the 7th one falls within the 5th and the 10th one for AABB. And then therefore the second one would fall in that range. So I'll just write it here in case it's not that clear in my explanation. So let's say we have 1, 5, 10. All of these are all possible permutations, anywhere from 1 to 2, or 1 to 5 and 5 to 10. All possible permutations of AABB. These are the permutations of starting with B, and then these are the permutations starting with A. And now we're looking for the 7th one, which means we want a permutation such that it's kind of midway between all the permutations of B. So then, therefore, out of the permutations of B, 5th is the first one, 6th is the second one, and then 7 would be the third one. So then our problem becomes equivalent to finding the third permutation within AAB. Okay, and now you might be starting to notice another recursive trend, because now our problem becomes equivalent to finding the third one within AAB. And now with AAB we can start with A, and we can start with B again. And then from A we can either have A and B. And then from B we can have A, but then we can also have A, which means we only have one choice basically. So then we can generate a few more over here. And then from B, this basically extends. And I'm sure you had the general idea of how the recursive code will implement. And now let's just have a quick look at the actual code itself. So pretty much, I'll come back to what these two lines do. It's a Python specific thing, but let's have a look at this f function. So this f function basically generates how many permutations are possible given a certain string. So that's pretty much what I was talking about as the first recursive function. So what it does is you obviously need to know how many letters there are and what the limit of letters are as well. So which is why these are defined as global variables. I also pass the parameter count to this particular function, which determines the count of the letters which are currently inside the string being passed to the function. Now, the reason why this is the case is because, this is basically, we know that once we've reached the total count, or once the count is equaling the limit, then we're basically finished all the characters we have left, right? So for that purpose, we have remaining as one of the variables passed to this. And if remaining has the value of 0, then we know we have no more letters remaining, basically. So then that means the total number of permutations of that particular substring is only 1, since there's only one way which we can get, since we can't add any more letters, right? So that's basically it for that particular substring. And then we return this. Otherwise, this is our base case, but our general case is this. For each of the characters in the letters, if the character is equal to the recentmost character, then we basically pass the function with the recentmost character as the first one, and then the count plus 1. Okay, I'll come back to this, but in case you didn't understand what the purpose of the recentmost is, it's because this f function, outputs the number of permutations starting with a certain character, which is what the recent character does. Since if you remember back in our whiteboard, we needed to know what the initial character was before knowing how many permutations were possible, right? Since, for example, if A was the first character, but then B was if A was the second character, or B was the second character, there would basically be a different number of permutations for each of them. So that is pretty crucial information for us to know how many permutations there are. Okay, and now after we've determined the first character, then we can basically apply this function recursively, since for each of the other characters, we can add their function values to the total, and then until all of them have fully been explored, in which case we know that our total has all possible substrings accounted for. So that's our f function. Now, if you notice, this is recursive, and the purpose of this LRU cache, it's basically a Python thing, because in Python the recursion depth is much smaller than other languages. So if we were to extend to like a few hundred, for example, or even like about 50, this would start getting very, very slow. But this LRU cache is a nice decorator which helps speed up the code by caching the results essentially. Okay, and now we take these specific inputs, p, limit, and max len. So I'll start with limit. Limit is basically the number of characters. Max len is the length of the string. Excuse me. And n is basically the nth type of nth sequence of the string which we want to output. So for example, we wanted the 7th string in the permutation of characters AABB. So in that case, the input would be 7. Okay, Now let's look at the rest of the code. So I'm just initializing some variables. I'll explain what they do a bit later. So rem is basically the remaining number of characters. It's obviously initialized to max length since before we started we have all possible characters remaining. And now what this while loop does is for each this basically decides what character is to be placed at each letter. And the way it decides this is if the number of permutations starting with that particular character exceeds our n, where n is the nth number which we want to print, nth permutation which we want to print. If that particular character exceeds n, then we know that character is suitable. However, it has to be like one of the earlier variations of that character. So just to explain what I said in a different way. So for example, back in our previous example, we knew that it had to start with B, since the permutations from B range from 5 to 10. So in that case, the upper limit would be 10, and what we want is 7. 7 is less than 10, so we know that it has to fall within that window of 5 to 10. And then likewise with the next thing. So we know that the first character is A, and the window for A would be from 5 to 7, and then 7 is less than or equal to the thing which we want to print. Therefore, we know that the first character has to be A. Then we apply this again and again. So the reason why we're initializing copy to whatever the initial prefix is because we will basically be modifying this copy. And the way we'll be modifying it is we keep on appending the letter which we think is the starting letter until we finally decide what the starting letter actually is. And again, the way we should decide the starting letter is the number of permutations starting with that letter. And we pretty much just repeat this again and again. So if letter equals the previous letter, then we basically need to increment the repeat. Otherwise the repeat's just 1, since the previous letter is unique. And if the repeat is greater than limit, then that's basically invalid, right? Since we can't have more repeats than there are characters. So then we basically just continue. And now what we do is we append the letter to our copy array, and we increment the I, where I is the counter of the current iteration which we're going over. And then if I is greater than n, then we know that that particular letter is the correct one. So then we set our prefix array to be identical to the copy. And we set our previous variable to be equaling the letter which we're currently iterating over. And then here's the important thing. We subtract off the number of permutations generated by this letter. Since, if you remember, back to our initial example, when we started with, when we were deciding the first letter, so then we know that the number of permutations of B ranges from 5 to 10. But then we can't just have i's equaling to 10. We have to subtract off 5, since it could be anywhere within the range from 5 to 10. So then we start alphabetically, so we start from the lowest, which is 5. So, and then after, finally, if we basically just pop that particular element from copy, and then we repeat the entire process, except now our copy is one length, now our pref array, is one length higher than it used to be. And now we basically just need to print the final output message at the end. So now let's have a look at if our code works against the mark scheme. So maybe let's just give it the final test case. And let's go back to the program. It indeed works. So now maybe let's give it one more. Okay, so this is what our program outputs. Now let's go back. And we can see it does match exactly. So that's pretty much it for this particular video. I really hope you enjoyed watching the video. I really hope you enjoyed watching this particular video. And hopefully you learned something new about recursive functions and how we apply them to order this particular question. And I hope to see you in another video in another time. Thank you very much for watching.